okay, which is 4 factorial is simply equal to 4 times 3 times 2 times 1. If you think about it, 4 objects, so there's 4, if 4 objects are in the bag, so there's only 4 selections I can make, and then the bag is empty. So the first selection, I could take any one of the 4 objects. The second selection, I could take any one of the 3 objects that remain. The third selection, I could take any one of the 2 objects that remain. And the last selection, I can only take 1 object, which gives us a total of, well, what's that? 4 threes is 12. Times 2 is 24, times 1 gives us 24. There's 24 possible ways, yes? 21 possible ways of arranging these objects, okay? And so these are how many particular arrangements that we can have, okay? Let's just move on and let's have a look at rule number 4. We're nearly there. We're up to the 2 big rules now that are going to be really important for us, okay? Which is the permutation rule and also the combinations rule. So this is rule number 4, okay? So this is rule number 4. So this is counting rule number 4. Okay, nearly there. We're nearly there. Let's just have a little bit more patience. Not patience yet, but just maybe let's hang in there a little bit longer. Yeah. Okay. And this has got to do with permutations. Permutations. Okay. This is all the ways we can actually arrange things. Yeah. Okay. And what it really says is this is the number of ways, okay, of arranging x objects, okay, x objects selected from n objects, okay, in order, okay, so the order is important, is, okay, a different notation for this, okay, so we'll just say we've got n objects and I want to select x objects from them, okay, so we have n objects and we want to select x objects. We want to know how many ways can we do that, okay, where the order is actually important, okay. Okay, the order does differentiate one thing from another, okay, so we have it's npx, that's one way to write this down, okay, which is simply equal to n factorial all over n minus x factorial, okay. This npx notation here is the same as, it's equivalent to the notation maybe something like this npx, or maybe something that you've probably seen like this npx. It's exactly the same notation. We've got n objects and we select x objects from the n objects. How many ways can we do that in total? Yeah, okay, if that makes sense. Okay, so for example, okay, for example, for example, okay, we have 4 unique objects, okay, okay, in how many ways? Okay, can 2 objects, okay, be arranged? Okay, okay, okay. The number of ways, in how many ways can 2 objects be selected? Okay, can be arranged and selected. Okay, and selected. I should have said selected and arranged. Yeah, say from the 4 objects. Okay. Well, in that case here, what we have is they're all unique. We're not going to complicate things just at this stage. Okay, let's just say consider that they're all unique objects. Okay, so we have 4 objects. Okay? And we want to select 2 from the 4, so actually the total number of selections is 4p2, which is equal to, well, the formula says this here now, 4p2, okay, I'm using this notation here, this is actually what I'm more familiar with using, okay, 4p2, 4 objects, so this is n, so that's our n, and our x is 2, so actually what it says is the formula is n is 4, x is 2, the total number of ways is n factorial divided by n minus x factorial, so it's going to be 4 factorial divided by 4 minus 2 factorial, which is the same as 4 factorial all over, well, 4 minus 2 is 2, so that's 2 factorial, which gives us, well, 4 factorial is 4 times 3 times 2 times 1. That needs to be divided by 2 factorial, which is 2 times 1. They cancel, which gives us a total of 4 times 3, gives us just 12 possible ways of actually arranging those particular objects, if that makes sense, when they're all unique objects. Okay. Now, where the order is important. The order, in order, the order is really important, and this is what's known as permutations. Okay, okay, that's really important for us here. Okay, and then let's just say the final rule that we have. Okay, counting rule, counting rule, number 5, which is our combinations. Okay, our combinations rule. Okay, so this is counting rule. This is counting rule number 5. Okay, it says, okay, the number of ways, okay, of selecting x objects, okay, from n objects, okay, irrespective, okay, of order, okay. That's important. The order doesn't matter, yeah, okay, is equal to okay, ncx, okay, so ncx, I'll use the same notation I used before, which is n factorial all over x factorial times n minus x factorial, okay. Don't forget ncx is the same as, from a notation perspective, n objects. We select x objects from the n objects, and this is the same as ncx, which is the same also as ncx, same way as writing it. Sometimes you might see it as ncor, which is the same as ncor, which is the same as ncor. Okay, c meaning combinations. Okay, if that makes sense. Yeah. Okay. So let's